Hello, good day and welcome. Today we'll be dealing with University of Abuja Physics post UTME past question 41. For which of the underlisted quantities is the derived ml2 t raised to the power of minus 2 correct? I, moment of a force. I, work. I, acceleration. A, it says I only. B, I only. C, I only. And D, I and I. Now this is a question coined from the topic dimensioning. Now in dimensioning, you should take note that your kilogram is for mass and the dimension is m. Your length, your meter is for what? Length, represented by L, and your time is represented in that second, is for time, and is represented in T. So now we find the dimension of these quantities and we look for the one that has m L raised to the power of 2 T raised to the power of minus 2 as their dimensions. Now let's find for moment of force. A moment of force is simply defined as the force multiplied by its distance. So moment of a force, let's call the force F, is equal to what? Force times the distance it covers. Now force is measured in Newton and distance is measured in meter. Now Newton is the same thing as kilogram meter per second square. Now that is Newton for you, because force is mass times acceleration and mass is kilogram, acceleration is meter per second square. Mass times acceleration. So now it means that our moment of force will be equal to kilogram meter per second squared multiplied by meter. Now this will give us what? Kg meter squared per second squared. Now if we substitute the dimensions, I told you that kg is m, kilogram is for what? Is for mass, and that's m. So we have that what? Kilogram, m, meter is for length, that's L raised to the power of 2, seconds is for time, T raised to the power of minus 2. Now you agree with me that the moment of force contains ml2 T raised to the power of minus 2. So you tick it. In a question like this, you don't just stop there, you solve for other values. Now let's check for work. Now for work, the formula for finding work is what? Force times distance. Now if you were following, you notice that what? We did force times distance for moment of a force and force times distance for work done. It means the work done and moment of a force will have the same unit because their formulas are the same. Force times distance. Let me circle it, and that's the same thing we're having here. Now I told you that for force times distance, when you solve, you have ml2 t raised to the power of minus 2, which is the same with this. So we can actually tick work too. Now we move over to acceleration and we solve for acceleration. Now acceleration A equals velocity over time, and the unit is meter per second squared. Now meter is L, second is T raised to the power of minus 2. So this one for acceleration is LT raised to the power of minus 2. Now this is actually different from ml squared T raised to the power of minus 2. So the answer in this for this particular question will be option D, I and II. You notice that I and II are correct, and like I told you, the moment of a force and work are the same, or they have the same units, and their formulae are the same. The moment of a force is what? That force multiplied by distance. The work done is also force multiplied by distance. So the answer to this particular question is option D. Thank you. Please ensure you subscribe to our channel for more videos.